So hello friends, in this video we are going to discuss about this particular example. Now once you have a closed loop on this example, so there are three resistors which are connected in series, and you know that if any two or more than two resistors are connected in series, let's say this is R1, R2 and R3, so equivalent resistor of series connected resistance can be given as sum of three resistance R1 plus R2 plus R3. So you have to find out first what will be the equivalent resistance. So in order to answer first question, you have to simply make a sum of all the resistance. Now first resistance is 10 ohm, so R1 is 10 ohm, R2 is 20 ohm and R3 is 30 ohm. Now if you substitute all those R1, R2, R3 in this equation, so equivalent resistance is nothing but 10 plus 20 plus 30 is equal to 60 ohm. Very easy, right? Now second is what will be the current flowing through each resistance. So for that we have to connect our all those three resistance across a supply. Now 230 volt supply is there, and it is not disclosed whether the supply is AC or DC. Considering right now this supply is AC in nature, DC in nature. Let's say if we have 230 volt source, then what will be the current? So second is I. Let's say current is given by I. This I is applied voltage divided by sum of all those three resistance, means equivalent resistance. So that would be given as 230 divided by R1 plus R2 plus R3, means 60. So 230 over 60 will result into some value of current. So that would be 230 divided by 60 is 3.84, 3.83. So 3.83 ampere. So that would be current which will be flowing through this all R1, R2 and R3. Now question 3, if you look at the problem statement, so we have to figure out what will be the voltage drop across each resistance. Now while current will flow through R1, R2 and R3, which is I, would be some voltage drop. So that we have to calculate. Now voltage drop across R1, R2 and R3 can be given as voltage drop across R1, R2 and R3. So as per Ohm's law, V equal to IR. So current flowing through the resistor R1 is I, and its self resistance is R1, here R2 and R3. Now what is I? So that we have already calculated 3.83. So you have to substitute here, and R1 is 10, similarly 3.83, because all the resistance are connected in series, so current will be equal through R1, R2 and R3, here 20 and 30. So this gives voltage drop across VR1, R2 and R3. Okay. So this would be the answer of question number 3, sub question of 3. Okay, now 4. Now in fourth, power loss. Now we know that what is power? Power is voltage into current. So in case of resistive element, power loss can be given as I square R. So we have to figure out power across 10 ohm, 20 ohm and 30 ohm. That would be I square into R1, I square into R2, I square into R3. Now it is I 3.83 square, 3.83 square into R, right? R in first case 10 ohm, in second case that would be 20 ohm, and in third case that would be of 30 ohm. So after calculation you will get power loss across R1, R2 and R3. Here you will get voltage drop, so it would be like 38.3 volt. That would be 2 times of this, so 3.83 times 20 would be 76 volt, and the last one 3.83 multiplied with 30, so 3.83 multiplied with 30 is 114.90. Now if you sum VR1, VR2, VR3, what is expected that VR1, VR2 and VR3 value sum answer must be the supplied voltage. So we know that our supply voltage is 230 volt, so that is what expected. So if you sum up, so the answer would be 114 plus 76, so 114.90 plus 76 plus 38.3, so that is 229, means very close to 230, right? That would be the correct answer. Now in case of power loss, here you have to take a square, so 3.83 square multiply with 10 will be 146 watt, 146 point something watt, let's say 10 watt, or okay, 68 watts. In the second it would be like multiply with 20, so answer is 293.37, and in last case it would be 440 watt. So that's it. This is all about solutions of question number probably 3 in the assignment. Yeah, that would be okay. Thank you for watching.